Okay, so for delta math practice, just in case you get stumped, we're going to work some together so you kind of see what their expectations are and can get through those as well. Also, practice always makes perfect. So, the beginning of spring, Savannah planted a small sunflower in her backyard. The sunflower height in inches is h after w weeks is given by the equation h equals 3.75w plus 11. What could the number 11 represent in the equation? So remember, 11 is our y-intercept, which is also known as your starting point. So that means that this flower, the sunflower, started at 11 inches and then is going to grow 3.75, and this would be per week. And that's where your inches and weeks come into play in your word problem. So the rate of change in the sunflower's height, in this case, it is not 11. That is the 3.75 inches per week. The sunflower's final height would be your H. So that's your output. So your input would be that the however many weeks that you were to track it, and then your output, your Y value, would be what would be the final height. The sunflower height after 1 week, that would be the 11 that she bought it plus 3.75. Because remember, W is your weeks, and the sunflower after 0 weeks. So if I plugged in a 0 here, this whole thing goes away, and 11 is all that is left. So 11, our y-intercept, is the sunflower's height after 0 weeks. All right, Anand's math teacher finds that there's roughly a linear relationship between the amount of time students spend on their homework and their weekly quiz scores. This relationship can be represented by the equation y equals 7.2x plus 55, where y represents the expected quiz score and x represents the hours spent on homework that week. So again, that means y equals score when you're done. X is going to be hours spent studying. So you decide how many hours you spend studying, and there's a relationship to that amount of time that's going to give you a certain score. So again, X is your input. That's what you get to control. And Y is your output. And Y is dependent on how much you study. So the study is independent. Just using some more vocabulary words for linear equations. So independent is what you get to decide your input, usually always your X value, and then your output, which is going to be your Y, is going to depend on whatever that X value you plug in. So, and then it asks us, what is the meaning of the X value when Y equals 77? Well, Y is our score. So we know this is going to be the score that the person earned. And then what is the meaning of the X value? So we'll read our choices. The number of hours a student would spend on their homework to expect a score of 77. So X is the number of hours spent. So this looks like a good choice. Let's make sure we don't have a better one. A student's expected quiz score if they spent 77 hours on their homework. So that's not going to work because the 77 hours is the X value, and they tell you that it's Y equals 77. So 77 is the actual score that they did score on the test. So then this is not correct. The change in expected quiz score for every additional 1 hour students spend on their homework. So this is going to be your slope, that rate of change. So you're seeing the word change. So the change, and that slope in this case is 7.2 because it's the coefficient of X. So the number in front of the X value. And then a student's expected quiz score if they spent no time on their homework at all. And I said test, sorry, on their homework. So no time studying at all. That would be that 7.2 times 0 plus 55, and this would cross out. So that answer would actually be 55. So they spent no time on their homework. They are predicted to make a score of 55. So we're going to go with our first answer. The number of hours a student should spend on their homework to expect a score of 77 on the quiz is going to be that X value. How long should you study to make a 77? All right. There's a roughly linear relationship between the length of someone's femur, the long leg bone in your thigh, and the expected height. Within a certain population, this relationship can be expressed using the formula H equals 2.41 F and 5 plus 54.8, where H represents the expected height in centimeters and F represents the length of the femur in centimeters. So make sure you're also reading that they're using the same units of measure, because that's another place they'll get you. Like sometimes they'll say inches and then feet, but in this case they're both centimeters. What could the number 2.41 represent in the equation? So looking at our equation, thinking y equals mx plus b. We know m is our slope, b is our y-intercept or starting point. Constant. That's another word for that. So in this case, we're looking at the 2.41f. So that's going to be our slope, and it is going to be the change. So as it goes up, for every inch in your, centimeter of your femur, so femur, for every centimeter, it's going to go up 2.41 centimeters. So the change in expected height for every 1 additional centimeter of femur length. Yep. The change is expected. The change in expected femur length for each 1 additional centimeter of height. So this is where you want to pay attention. When they use F and H, it's great because you know the difference. But you want to make sure you read H represents height and F represents femur. So it's not the change in expected femur length for 1 additional centimeter of height. This is where the 1 would go. So it's the femur length. So they've got our X and our Y mixed up in this choice. The expected height for someone with a femur length of 2.41 centimeters. This does not say that the femur length is 2.41 centimeters. This is saying that's going to be the increase for whatever centimeter addition we do of femur length. The expected height of someone with a femur length of 54.8 centimeters. So this is going to be the height in general. That's where we start. And then it's going to add 2.41 per femur. So this is actually still height. It's height, output, height. The only thing that deals with femur is your F. So it is going to be the change in expected height for every 1 additional centimeter of femur length. All right, I got one more for you guys. And then we'll switch over to graphs, and we'll do that in a separate video. So Lauren is preheating her oven before using it to bake. Lauren wants to predict the final temperature after X minutes. She wrote the equation y equals 76 plus 20x, where y represents the final temperature in degrees in Fahrenheit. What is the meaning of the y value when x equals 1? Now, this is in y equals mx plus b form, just out of order. So that's 20x plus 76, if it makes more sense for you to switch them around. And we want to know what is the y value when x equals 1. So that means we're going to solve for 20 times 1 plus 76, which is going to give us 96. And that means that our x value, it tells us, is minutes, the final temperature. So the final temperature is what we're predicting after x minutes. So x, our input, is going to be minutes. And our output, or y value, is going to be final temperature. So the oven's temperature after 0 minutes would be your y-intercept, your starting point, because that's going to take away that 20 altogether, so that's going to be 76. The change in degrees Fahrenheit for every change of 1 minute, that looks good. The time when the oven's temperature is 0, so that 0 would then be y value. So that would be what would make this into a 0, which if we're talking temperature of oven, it wouldn't be time, not necessarily in that way, because then you would get some negative here, which we don't have negative time. So that would be an absolute value conversation. The oven's temperature after 1 minute. The change in degrees Fahrenheit for every change of 1 minute. Oops, what is the meaning of y? This is not good. The change in degrees Fahrenheit for every change of 1 minute, that's going to be your slope. Whoops, I got excited. Slope, so that's your m value of 20. The oven's temperature after 1 minute is going to be the output, which is the y value when we plug in a 1 for x. So it is going to be the oven's temperature after 1 minute. All right, so that's our word problems, guys. See you next video for our graph interpretation.